Good morning. Today we are continuing with our polygons. We are doing CO65. I can identify polygons as similar or congruent. So as we were just talking about in class, we will be doing our final test on this at the end of next week. So we will be done with our COs by Tuesday. Wednesday will be a review day next week. Thursday will be practice test, real test next Friday. Keeping in mind that this Thursday is our math testing, so we're not doing a CO this Thursday. We will be taking our time and going slow, checking our work on the math test. That is the big thing when we're taking that math test. We know our material. It will throw stuff at you that is new. Use what you know to answer the new questions. You will get some questions. They will be throwing challenging questions at you, but don't be scared. Don't think, oh, just because it's something that I don't know, I can't figure it out. Use the knowledge that you know to answer it. Anthony.
When's the last deal
Of this
of this year?
Oh, honey, I'm just doing one unit at a time.
When's the last unit? Next unit?
Our next unit. We have this unit and one more unit.
So
No, it's not gonna be really, really long, because there's only 26 days of school left. It will take us up to the end of the school year. Because, like I said, we've got field trip and track and field day. There's lots of stuff happening. Okay, friends, let's focus. Stop with the conversations. Let's focus. Today, we're doing I can identify polygons as similar or congruent. What does congruent mean? We've learned this already, Will W. All the sides and all the angle measurements all are the same. So lengths of sides are all the same. Angle measurements are the same. So think of a square. All right angles, side lengths of a square are all the same. Would a rectangle be congruent? No. Why not, Will? Because two sides are long and two sides are short. They're not all the same. So a rectangle cannot be congruent. To be similar, they need to have the same shape, but not necessarily the same size. So if we have a rectangle like that and a rectangle like that, I squished it in a little too close. So a rectangle like that, they can be similar, but they're not congruent. They're not the same sizes. So similar polygons have the same shape and same size. For congruent polygons, corresponding angles are congruent and corresponding sides are congruent. So I said that wrong. I was thinking of just one square would be congruent. We could have congruent rectangles. We're looking at the exact same sizes. If your two polygons that you're comparing are the exact same, then they are congruent. If they are the same shape, just one is expanded, then it is similar. So congruent means the two polygons are identical. Similar means that it's just taking the small one and kind of growing it out to be bigger, same shape. So finding measures of congruent polygons. Triangle RST. So let me draw triangle RST. RST. Imagine that these are straight lines. For some reason, my board is not going straight for me. Let's say this is 6 inches. This is 8 inches, and this is 11 inches. Now I have triangle X, Y, Z, X, Y, Z. They are congruent. Here's the important thing to make note of. The order that they put the letters is important. So for our first triangle, it was R to the S to the T. So this one is X, Y, Z. So X, Y is first. Here, RS is first. So those are the two segments, the two sides that are congruent. Does that make sense? We have angle RS T X, Y, Z. So RS is congruent to XY. So right here is congruent to right here. Even though it's turned, that triangle is turned, you have to match up the correct sides. So RS goes with XY. Then we have ST goes with YZ. So then TR goes with ZY. Do you see how you match them up? We're not going to say that this is the same as this because they don't match up. They turned the triangle. I'm really not sure what's happening. I see 4 of us giggling at each other, and it's incredibly distracting and disrespectful. Your attention should be up front. We don't need calculators out. So put it down. This is something that confuses a lot of people. They automatically think, oh, this line and this line go together because that's what it looks like it would be, but the triangle was turned. You have to look at the letters. You have to look, it starts RS, so, and this one starts XY, so it's the RS is congruent with the XY. So you have to look at your letters. Does that make sense?
Yes.
So if our question is, oh, it just says name the corresponding sides and angles. So I told us our sides, if RS goes with XY, ST goes with YZ, and RT goes with ZX. What are the corresponding angles? Which angle goes with angle S? Look at, if angle S is on this triangle, we want what angle from XYZ goes with it? Bria? How did you know it would be angle Y? Just looking at the name of our triangles will tell us. Where is S in our name? It's in the middle. RST. So look at XYZ, the one in the middle, is going to be congruent with it. So what angle is congruent with angle R? Gregory?
X.
Angle X. They are the first ones in our triangle name. What is congruent with angle T, Peyton? Angle Z. So you have to look at your triangle names and be matching them up. You can't just look at the picture and go, well, I think they look about the same, so they must be. We have to use our evidence, okay? We have to look at the names. All right. Finding the ratio of lengths, similarity and scale factor. If 2 polygons are similar, remember similar means same shape, different size. If 2 polygons are similar, the ratio of the lengths of the corresponding sides is called the scale factor. So I'm going to erase this and move it up so we can see it better. All right, so given that angle ABC, triangle ABC is similar, because we've got that squiggle, I don't think I pointed that out. If it is similar, it's going to have the squiggle line. That means they're similar. If they are congruent, it has that squiggle sign plus the equal sign. So similar is just the squiggle. Congruent is similar and equal. So they are the exact same if it has the equal sign under it. So for number 2, it has just the squiggle, so we know it's just similar. Same shape, different size. So we have triangle ABC. And then we have triangle DEF. Similar shape, different size. Find the ratio of the lengths of the corresponding sides of triangle ABC to triangle DEF. So I'm going to put some measurements on here. So 16, 20, 28. And then we have 12, 15, and 21. So those are our side lengths. So we want to write a ratio for each pair of corresponding sides. So this one, we don't have any triangles turned. They correspond exactly to the same positions because no triangle is turned. So AB goes with DE. So AB is 16. You know what? Let me write it out. AB is 16, and that corresponds to DE, right? AB goes with DE, and that's 12. This is how we're going to find our ratio. What do you think I need to do to 16/12? A ratio we want to leave as a fraction, but what do I have to do to that fraction?
Oh, I know.
Anthony?
I
I need to, what do we call that, Tristan?
simplification.
I need to simplify. I need to bring it down so I can divide a 4 out of both. 16 divided by 4 is 4. 12 divided by 4 is 3. So AB to DE is 4 to 3. That's how much smaller I'm making that triangle. That's the ratio of how much smaller it is. So let's look at another set of corresponding sides. BC corresponds to what side? Mia?
EF.
EF. So BC is 20. EF is 15. Can I simplify it? What can I divide out? I heard somebody say it louder.
5.
5. 20 divided by 5 is 4. 15 divided by 5 is 3. One more set of corresponding sides. What are they? Brielle? AC. To what? DF. AC is 28. DF is 21. What can I divide out of both of them? 28 divided by 7 is 4. 21 divided by 7 is 3. What do we notice about their ratios? They're all the same. So they're all shrinking down the same rate. That's how we know it's identical. Okay? It's the same shape. It's just going smaller by the same rate. 4/3, 4/3, 4/3. So we know that they are similar triangles because they went down the same rate. That ratio is the same. So our scale factor, the scale factor is 4/3. Your scale factor is that ratio that they all share in common. That is the same thing as the scale factor. Checking for similarity. An art student is copying a detail of a painting. The copy is 48 inches long and 36 inches wide. So our copy is big. The original rectangular region that she's copying is 16 by 12. So this is our original. This is the copy. The original was small. She's making it big. So we had 48 inches long, 36 inches wide. This one is 16 inches long, 12 inches wide. Are the original and the copy similar figures?
Yes.
How can we figure it out? How would we know if they're similar? What did we just do?
Simplifying.
Simplifying what? What did I have to find? I have to find the ratios and simplify and see if the ratios are the same. So I have my length of 48 over my length of 16. What can I divide out of 48 that I can divide out of 16? 3 out? How many times? 48 divided by 3, or sorry, not dividing it by 3, dividing it by 16. 48 divided by 16 is 3, 16 divided by 16 is 1. Oh, and I actually flipped it. I put the length of the original on the bottom. So, sorry, my bad. The original should be on the top. The original was 16. The copy should be on the bottom. Still dividing it by 16. So the original is on the top. The copy is on the bottom. So now we're going to do the same thing for our width. Because we need to know, is the ratio the same? So I have to do it with both. I have to do it with the length and with the width. So what is my fraction for the width? Peyton?
What are we at?
The width of the original over the width of the copy. So my original is 12 over my copy.
I was saying like you divide it by.
I can actually divide it by 12.
Oh.
12 divided by 12 is 1. 36 divided by 12 is 3.
I just saw like.
So our question is, are the original and the copy similar figures? How do you know? You said yes. How do you know that they are similar? Mia?
Because, like,
That scale factor is 1/3. The ratio for both the length and the width is 1/3. So we know they are similar. So we know it is similar because our scale factor is the same. That scale factor is 1/3. So they are similar. Does that make sense? Thumbs up, thumbs down, shaky thumbs. How are we feeling? Okay, some of us are a little shaky. All right, we're gonna do the workbook page and see if that helps solidify it. Sometimes when we just work it out, it starts to click for us. So our homework for today is page 135, 136. For my friends at home, we hope you are well, and we hope to see you soon. Was I not recording this?
I don't think so.
Oh, I am.